No conversation on color would be complete without a conversation on color space. And color space is a range of colors that a device or a program like Fusion can work with using a particular color model. Because this is a digital compositing program, we're using the RGB or red, green, blue model. Now, in terms of the range of colors that Fusion can work with, it's actually something you can set. File, Preferences. In the Frame Format section, you'll see a color depth area. By default, it's set to 8 bits per channel. That means that each color channel has a maximum of 8 bits of color variation. In other words, 2 to the 8th power, or 256 color steps. Now, 8 bits is often suitable for many operations. In fact, some of the output formats only support 8-bit. You can change these menus to a higher bit depth and get greater accuracy. For example, you can choose 16-bit or 32-bit. The higher the bit depth, the more colors per channel, and the greater accuracy. Now, there are two variations. There's integer style and floating point style. 8-bit is always integer. There's also a 16-bit integer, and then there's a 16-bit floating point called float, and also a 32-bit floating point. Integer bit depths round off values. So, for example, with 16-bit integer, a color value might be 100 or 300, something that's rounded off. Floating point supports decimal accuracy, so a color value might be 100.276542. Floating point decimal accuracy also supports the ability to have very, very small values like 0.000001 or extremely large values such as 10 to the power of 256. So the thing to remember is the higher the bit depth, the greater the accuracy, and also floating point is always more accurate than integer. So the maximum quality here is 32-bit float. You might not be able to see the additional accuracy in your monitor. Most monitors are 8-bit or 10-bit. That means the range of colors they can display is much smaller than 16-bit float or 32-bit float. Nevertheless, by switching to one of those formats or one of those color spaces, you're guaranteed greater mathematical accuracy. For example, let's say I put a very heavy blur on this footage. With 8-bit, that might produce color banding, where you see colors suddenly change, which is also called posterization. Now, if I do that same heavy blur with 16-bit or 32-bit, the blur will appear much smoother. So the mathematical calculations that happen are more accurate. And even though I can't see the full range, say, of 32-bit, I still see an improved quality in my 8-bit view on my 8-bit monitor. So sometimes if you need greater accuracy, you definitely want to switch over to 16-bit or 32-bit. And in fact, there are some output formats, some formats you can render that do support 16-bit or 32-bit float. For example, if I was to render out an OpenEXR image sequence, those images will support 32-bit float. Now, when you change these menus, they're all locked together by default. And these are divided into certain tasks. For example, full render quality, which is your high quality render, preview render, which is your preview render, which is lower quality, and interactive, which is basically what you see through your view. If you'd like to change these menus individually, just turn off locked depths. For example, I can leave full render and interactive to 32-bit float, but change my preview to 8-bit. Maybe I don't care about my preview quality, I'm just roughly checking to see what's going on. In any case, once you set these menus, just click Save. This is something you probably want to do at the start of a project.